everybody, it is I, your all-time favorite fool, Richard Blyle. Here I want to talk a little bit to you about try this again, take two. We're going to talk to you a little bit today about the difference between an analog circuit and a digital circuit. Here's the background on this. I used to teach at a university that was known as the tech school. Now, they're doing a lot better now, I'm told, but there was a time when, for the state tech school, they left a lot to be desired. They seemed to think that teaching technology meant teaching the latest gadgets. Now they're much better. Their program is a lot stronger. We had people complaining that their computer science majors were graduating without ever having been inside a computer. That's not a good thing. I had a student come to me one day, very excited. He said, if you need any circuit, I can design it and build it for you. Just tell me what you need and I'll do it. I said, well, that's fantastic. Now, I know a little bit myself, but what the heck? I like supporting students and their enthusiasm. So I said to him, look, I need a circuit. Now, back then, I was still, they didn't spend money on chemistry, honestly. So I was using very old equipment, and I had an analog fluorimeter that printed out to a plotter. So basically, the paper would come out this way, and the pen would just move back and forth. So you got time by the paper movement and amplitude by this. And so you'd end up with these paper plots. Well, that's fine and dandy, but I wanted to capture it to computer. Now, I knew how to do this, and eventually I did. But I said to my student, look, I need a circuit that will, it's called a digital to analog to digital converter, or ADC. Can you build one for me? And he responded and said, what's analog? We are so used to digital these days. They digitize everything, and I don't always understand why. If you want to know the God's honest truth, there are some things that work just fine without going digital. So let's talk a little bit about analog versus digital signals and equipment and things of that nature. Back to our lovely chalkboard. I'm really glad to use this chalkboard in these, because this was a damn expensive chalkboard, and I like using it as much as I can to at least justify a little bit the expense of this chalkboard. But here's the difference. An analog signal can go anywhere from its minimum to its maximum value. Okay? When you're in your car, the velocity is analog. You start off at 0 and you go from 0 to 60, and you can go anywhere in between, anything that you want. So an analog signal, for example, if you had a sine wave, might look a little bit like this, where this is, by the way, the current coming into your house when you plug something into the wall. That's analog. It comes in as a sine wave. And it goes from negative 110 volts to positive 110 volts with a frequency of 60 hertz, which means you get one complete wave. I'm sorry, it takes, in 1 second, you get 60 complete waves back and forth from negative 110 to positive 110. That's analog. It can have any value that you want. Digital, on the other hand, only has two possible values. It is either on or it's off. You cannot go anywhere else. In a lot of digital, I've been playing lately with this Arduino circuit board, controller boards, and basically the voltages go from 0 volts to 5 volts. But you cannot get actually, well, let's not go there. That's a kind of a detail I'm going to ignore. But you cannot go anywhere in between. You can't go 2.3 volts. Well, 2.3 volts is here. Analog, it's not possible. I'm sorry, in digital it's not possible. In analog it is. So in analog you hit everything from the maximum to the minimum. In digital it's either on, which is 5 volts, or it's off, which is 0 volts. That's the difference. Now, with that digital, you can do a lot of things. And I have 2 examples for you. And I'm going to turn off my lens. I'm going to cover it up so you don't get seasick as I relocate my thing. So, let's see if I can do this. Can I see this? This is an old-time radio. Now I have a couple of probes in here. I'm going to show this to you, the front of it. It's really a beautiful radio if you want to know the truth. But there are no digital circuits in this. This thing was made maybe in the 70s, long before printed circuit boards, well, not printed circuit boards, because this is a printed circuit board here. But you can see all of the components inside the printed circuit board. These are all components. These are all electrical components. There's not a printed chip anywhere. There's not a computer chip anywhere. Now I have hooked this up. This gray, and there's another little, it's hard to see, another little black wire leading off of it. The black one is for ground. And I want to see the circuits here. Now this is, with these probes sticking in, this is not a real stable radio. I found a decent station, but I can't really, it's going to come out fuzzy. So I have connected this, where am I? Is this my oscilloscope here? Where's my oscilloscope? I have connected this to my oscilloscope. And I want you to notice this screen here. This screen is telling me the voltage along here versus frequency here. And as I turn up the volume, I want you to notice, now we're going to get a lot of jagged little blah 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 in here, a lot of noise. That's the sound, okay? That's the sound coming out of the speaker, because I have this hooked up to the speaker. But I want you to notice I can make that sound pretty much as large or as small as I want. There's that noise I was telling you about. But notice that every volume between 0 and whatever the maximum is, I can get it to any voltage I want. That's analog. The frequency there is the frequency of the notes. You started getting some square, some topped out ones here. That's because you're sort of maxing it out. And you start getting those flat tops. Those flat tops are because you're maxing out the equipment. So it really can't see it well. I'm going to very carefully try to detach this. I can figure out how. Come on, baby, let go. Because I want to put this radio back together. This radio is too beautiful for me to ruin. So I don't want to ruin it. There we go. That's an analog device. Minimum to maximum. Oops. That's not attached anymore. Come on, meow. There we go. And I am looking forward to putting this back together again. have a nice little radio. Oh, and here's the radio itself. Let me zoom back out. So here's the radio. Really nice, nice little radio. Has a couple of knobs here. This is band select here and squelch here. The volume knob, this is your on, I can figure out how to get it on here. This is your on-off knob in the middle. This is your tuner knob on the outside. That's my radio. If you want to look it up, it's a General Electric. It's a CB monitor. They don't see a model for it. Anyway, that's my analog device. Now let's look at a digital device. I built, again using Arduino, a little dirigible. Yeah, this is a dirigible. I built a little digital circuit here. Now, for this circuit, this is controlled by a controller chip here. This is completely digital. The other one was analog. Have I been saying the wrong thing? I may have. This one is analog. This one is digital. The other one was analog. I put a little indicator light here. And you can see it's either on or off. And I put a couple of places here for my probes. So let me attach my probes to this and let's look at the difference between the two. There's that one. Since I built this circuit myself, it was so much easier to just add spots specifically for the probe. Now let's get this to a point where we can see it. My frequency is too low, but notice that the voltage is jumping back and forth between 0 and 5. Actually 1.76. But I want to adjust my my trigger. There it is. There. So notice that it's either on or it's off. And it's going back and forth. And if you look at the circuit, can you see the circuit in here? If you look at the circuit, you'll see the circuit is doing, basically going with that signal. That's digital. Digital is either on or off. Now, there are things you can do with digital. This has a delay of 0.1 seconds. I can change that. So, for example, and this takes a second or two to actually kick in, so I can make this faster if I want. I'm sorry, this is 1 second, not 0.1, but I can make it 0.1 just by doing this. Now it takes it a minute to upload, not a minute, it takes it a couple seconds to upload, but you'll see suddenly it's going to start blinking faster, and we're going to get a faster signal here as soon as it's done uploading. Come on, meow. Did it do it? Is it done? Now, suppose I want this dimmer. There is no way to get this so that it's 20% power. It's either on or it's off. That's all there is to it. So it's either 5 volts, it's on, 0 volts, it's off. But there are tricks. suppose I do this. This should look like it's about 90% once it uploads. So it should look like it's on continuously. There we go. So now it's on continuously except for these dips down to 0. This is how digital Christmas tree lights work. Let's do something a little more obvious. Let's see if this is more obvious. If you buy Christmas tree lights and the manufacturer wants it to be able to go a little bit dimmer, they can't, because most Christmas tree lights today are digital. They're LEDs, just like this is. But what they can do, see, now it looks dimmer, because now it's turning off a little more frequently. Did this upload? Yeah, this uploaded. What it's actually doing now is it's flickering. Every time it hits 0 there, that's a flicker. So I can turn it down even more. Let's see how this works. Oops, that's not going to work if I do that. Made a mistake. There we go. Nowadays, a lot of people have a hard time with modern Christmas lights. It tends to give them headaches. This is the reason. Consciously, you can't see this flicker. Now watch this. It's going to start flickering a lot faster now. This is dimmer. But look at that flicker. Look at how much that is flickering. We are still going off and on, but it's going off so frequently that this is now about 10% of its original luminosity. The problem with this is that some people, even though you can't consciously detect that flicker, some people pick it up subconsciously. And when they do, it causes headaches, has the potential to cause, what's the word I'm looking for? Or you have fits, epilepsy. Has the potential to cause epilepsy. So I can make that light go brighter or darker by how long it's on and off. But at each of those cycles, it's still either on or off. There is no other choice. Analog goes from minimum to maximum and any value in between. Digital can only go on and off. We can change the frequency between the on and off, but we can't change the voltage. These Arduino boards actually can. They have two outputs. One of them is 5 volts, the other one is 3.3 volts. But still, even at 3.3 volts, there's only so much you can do. So it's still either 0 or 3.3, and most of these are 0 to 5. I feel like I was a little bit convoluted in this, so I hope it kind of made sense. But that's the difference between analog and digital. This light up here, it's driving me crazy. Let's try this. Ooh, I should have done that mood lighting. Ooh. And with this mood lighting, I tell you, I'm feeling very romantic. So you're lucky that I am out of here.